All right, welcome to Friday. Hey, hopefully you got over the mistake I made on the page number there for the homework on 12.2. Should have been 485, 486. Apologize for that. All right, go ahead and get out your homework. Let's see, it was 1 through 16 all. So question number 1 through 6 had what, 2 answers each time. So here we go. Number 1, the base edge was 6 and the lateral edge was root 34. Number 2, the base edge was 10 and the lateral edge was root 194. Number 3, the slant height was, that's L. L was 25 and the lateral edge was root 674. Number 4, the height was 3 root 7 and the base edge was 18. Number 5, the height was 3 and the lateral edge was root 41. Number 6, the slant height was 2 root 17 and the base edge was 8 root 2. Okay. Okay, so 7 through 10 you had to sketch, and then the lateral area, obviously I will just call out the lateral area. Remember, the lateral area is just the sides, not including the bottom, the base. All right, so number 7, the lateral area was 36. It should say 36 square units. It doesn't. Number 8 is, looks like they rounded to the nearest hundredth, 33.75. Number 9 is 192. And number 10 is 360. All right, for 11 through 16, the rest of the homework, it says sketch, then find its lateral area, its total area, that's the surface area, and the volume. Okay, so for number 11, the lateral area is 60. The surface area or the total area is 96, and the volume is 48. And they're just throwing caution to the wind, no units there. Remember, lateral area will be in square units, total area in square units, and volume in cubic units. All right, number 12, lateral area is 320. Surface or total area is 576 and the volume is 512. Do not be concerned that the volume is smaller than the surface area. They're two completely different units. All right, number 13, lateral area is 260. Surface area or total area is 360 and the volume is 400. Now the numbers are as we would expect them to be. And number 14, lateral area is 480. Total area is 736. And the volume is ugly, 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 ugly. 256 times root 161, all divided by 3. All right, number 15, the height is 6 centimeters. And the last one, number 16, the slant height is 5 meters. There you go. There are your answers. Answer question 1 on the Google Forms. Okay, today we're going to do cylinders and cones. Cylinders and cones. On Monday we'll have a quiz. So let's see, what will the quiz be on? All we've been doing is lateral area, surface or total area, and volume. What shapes did we do? On Monday we did prisms. On Wednesday we did pyramids, and today we are doing cones and cylinders. So that's what the quiz will be on. So let's see, how many shapes? Prisms, but they come in 2 flavors, rectangular and triangular. So let's see, 2 questions on that. And then we did pyramids. I'll just give you a square pyramid. I won't cause it. So let's see, 1 question on that, and then cones and cylinders. 2 questions, 5. So let's round it to 6. I'll give you 6 questions on. I'll probably just do surface area. I won't do lateral area because it's part of the calculation for total area, right? So I'll just give you a surface area question on prisms, pyramids, cones, and cylinders. And then volume questions on those shapes as well, too. Make sense? If not, send me an email. And it will be multiple choice. And yes, you can use calculators. Okay, here's your homework tonight. Hopefully I wrote down the right numbers. I'm checking right now. And yes, I did. Okay, cylinders and cones. So different day, same drill. We're going to be doing 3 things. Surface area, lateral area, volume. Now remember the book calls surface area total area. I'm okay with that, but most books call it surface area. All right, and the shapes we're doing are cylinders and cones. So we'll do one at a time. All right, cylinder. Cylinder is a three-dimensional object with two congruent circular bases. That means, well, in this particular orientation, the top and bottom are circles. Now, when we draw them in two dimensions, we make them more oval shaped, so it looks right to our eye. And just remember, the bases don't have to be the top and bottom. You could turn this on its side, then it would be left and right, or front and back are the bases. But the key point here is that the bases are circles, and the two circles are congruent. And then you have a curved surface that joins them, right? There's no flat surface, right? So let's see, prisms have parallelograms, pyramids have triangles, cylinders don't have any of those, right? It's a curved surface. Okay, that's the side. The sides are made up of a curved surface. All right, so draw me a cylinder real quick and let's label the parts. Now, yes, we generally draw our cylinders where the top and bottom are the circles, but it doesn't have to be that way. So for this particular one, the bases are those circles, although they look like ovals when we draw it. And one key note here is to notice that the circles are also parallel to each other. Okay. All right, and then I guess the biggest key point there is they are congruent. So two congruent circles that are parallel to each other, those are called the bases. The lateral area, some books call it the lateral surface, right? The lateral area is that curved surface that joins the two bases, and it is the side of the cylinder. Lastly, the perpendicular distance between the two bases is called the height. All right, well, that kind of makes sense. Notice I also labeled R here, and yes, we'll be using the radius of the circle. All right, there's two types of cylinders, and it just coincides with the same thing for pyramids. That is a right cylinder. That's where the height goes from the center of the two bases. And then you have an oblique cylinder where the height is still a perpendicular distance between the two circles, but clearly it would not go through the center of both bases. Today and tonight for homework, we will only be dealing with right cylinders. There's nothing wrong with obliques, but we'll only be doing right cylinders. All right, think about this. In order to do surface area or total area, we got to think about, well, what's the surface of this shape? And what we use typically to help us understand that is we make a net. In other words, we peel off the skin of the cylinder. Okay? If you peel off the skin, maybe you did this in pre-algebra. If you peel it off, you get this weird looking shape right here. Notice we've got our two circles, those are the bases. And if you were to cut the two circles off, you'd be left with a tube. Now cut the tube straight down perpendicular, it makes a rectangle. Imagine that, a rectangle. So the net, in other words, the surface of a cylinder, is a rectangle in two circles. Well, luckily for us, that makes our life easier. Oh, by the way, the height would be that measurement on the rectangle. What would be the other? I mean, a rectangle, remember, the area is length times width. Well, what would be the length of this rectangle? Where would that be on the original cylinder? Well, that's the part that wraps around the bases. And if you go around the outside of the base, outside a circle, we call that the circumference. So it turns out for that rectangle, the length is the circumference of one of the bases, and the width is the height of the cylinder. Does that make sense? If I talk too fast, rewind. Listen to that again. It's important that you understand. I mean, the two circles, we got that part. But where does that rectangle come from? If you didn't understand that, immediately play that again. Okay. So the lateral area, or some books call it the lateral surface, is literally length times width, or in other words, the circumference, formula for circumference is 2 pi r, where r would be the radius of the base times the width, and the width here is the height. So there's your formula for lateral area, 2 pi rh, where r is the radius of one of the bases, and h is the height of the cylinder. This is actually theorem 12.5, lateral area, 2 pi rh. The lateral area of a cylinder equals the circumference of the base, that's 2 pi r, times the height of the cylinder, h. And there you go, lateral area, 2 pi rh. Book of truth, please. Good? Okay. So let's talk about the surface area, the total area. What pieces did we miss? Well, we know the lateral area is 2 pi rh from 12.5. Oh, by the way, I proved that to you if you didn't notice that. 2 pi rh then what do we got to add to that to get to the total area? We got to add the two circles. In other words, the two base areas. Remember, capital B stands for base area. By the way, this is what will appear in the book. If you look at their examples, they write surface area, total area is equal to 2 pi RH plus 2b. But couldn't we just couldn't we make this more user-friendly instead of putting a capital B? Well, capital B stands for the base area. The base in this case is a circle, and we know the area of a circle, it's pi r squared. So I would prefer that you use, and I'm not sure why our book didn't choose to write this. They don't even write this. That is the formula in yellow there that 99% of the books I've ever read will write. 2 pi RH plus 2 pi r squared. That is the formula for total area. Notice I put SA for surface area. So total area tonight for homework, when they ask you to calculate the total area of the cylinder, that formula there in yellow is what you're going to use. Now remember, R stands for the radius of the circle, and H stands for the height or the perpendicular distance between the two bases. Make sense? Okay. And then lastly, if you think about just circles stacked upon one another, right? This is where the volume formula comes from. It's just circles that are stacked. How many are stacked? Well, that would be the height of the cylinder. And that's probably the easiest proof that we've ever done right there. So let's see. Volume, V for volume, is equal to pi r squared H. Make sense? This is 12.6. The volume of a cylinder equals the area of the base times the height of the cylinder. I know my teacher always would talk about pizzas that are stacked or pancakes that were stacked, and it just made me hungry. So, I said it as well too. Okay, so let's just do a couple for practice. There's a cylinder. They gave you the radius. They gave you the height. They could also give you the circumference. They give you the circumference. From that, you could get the radius. And then use that for the total area as well too. But they do have to give you something about the height there. So we know, this is the useful formula, not the one that's in the book. This is the useful formula. Surface area is 2 pi RH plus 2 pi r squared. Now we're going to be calculating the total area or the surface area. This is just plug and chug. So let's see, the height is 4, that's your H value. And the radius is 5. Now they could give you the diameter. Just remember, if they give you the diameter, cut it in half. But this is simply just plug things in. Now all the answers they want you to leave in terms of pi. Do they say that in the instructions? I'm looking at the answers. All the answers are left in terms of pi, and they don't. So just remember, leave all the answers in terms of pi. What does that mean? That means don't multiply by 3.14. So let's see, 2 times 5 times 4 would be 40. 5 squared is 25. 25 times 2 is 50. You see where I got those numbers from? And 40 and 50 is 90. Now we were doing total area or surface area, so therefore the units will be squared. Make sense? Okay. All right, do a quick one for volume. Volume, we just need the radius and the height. We got the radius and the height. Once again, we'll leave it in terms of pi. 5 squared is 25. 25 times 4 is 100, so we get 100 pi. But remember, the units would be cubed. We could do 20 more examples, but they really aren't that much more challenging than that right there. Obviously, in homework tonight, they love this table thing. Eventually, they're going to give you the lateral area. I don't think they ever give you the total area, but they do give you the lateral area without any of the other dimensions. So just remember, the lateral area is the 2 pi RH. Lateral area, remember, equals 2 pi RH. Okay? All right, here we go. Next shape, the cone. Cone will be the first object that I can't prove everything to you. You need some calculus for it. All right, remember I said there's just a few things in geometry, high school geometry, that you can't prove. This will be one of them. All right, but they will prove this to you. It's one of the things they always do in calculus, and they'll say something like, hey, remember the teacher said in geometry that the volume of the cone was this, and they didn't prove it to you, now we prove it to you. They leave it to calculus. All right, so a cone is a three-dimensional object with a circular base and has a curved surface that curves to a point, the vertex, okay? Parts of a cone, obviously the base, in this case the base is a circle, right? We draw it with a little oval. The lateral area or the lateral surface is the sides of the cone, side of the cone. And lastly, the height is the perpendicular distance between the base of the cone and the vertex. Lastly, we do have one other thing. If we were to measure the distance along the outside of the cone from the bottom to the top, just like on a pyramid, we call that the slant height. And that would be the perpendicular distance from the edge of the base to the vertex. Okay? All right. And just like a cylinder, you have two types of cone. The first one's going to be called that's correct, a right cone. And that's where the height goes from the center to the vertex. And the second one would be an oblique cone. An oblique cone is where the height does not go to the center of the base. All right, we will only be dealing with right cones today. All right, think about this. Ignore that ABC there. My animation's off a little bit. If we were to draw a net of a cone, so if we were to cut off the circle, the bottom or the top, depending upon how you want to think of your cone, of the cone, what would that curved surface, if we laid it flat, look like? Can you imagine that? Well, here is the shape. Here is the shape. So there is the shape of what it would look like. Okay, so I'm about to show you where the surface area or the total area formula comes from. And it's a little complicated, so I'll try to slow down. You might want to pause. All I'm trying to do is prove to you where the formula comes from. The actual formula is pretty easy to use. All right, so I want to find first so it's made up of the lateral area and the base. The base is a circle. That's pretty easy, pi r squared. The lateral area, that blue part of the picture there to the right, right? Well, it's a part of a circle. You can clearly see that. And if I were to calculate the area of that, when we did that last chapter, that's called the area of the sector, right? So that sector ABC, right? If I were to calculate its area, that would be the lateral area. Well, do you remember what the formula was for sector? Well, the formula for the sector of ABC is the percentage that blue takes of the entire circle, not the orange one, but the blue one, right? The percentage of it times pi r squared. Remember, pi r squared would give me the area of the entire blue circle. And then if we multiply that by the percentage of the entire thing, then that would tell us its area. Well, we have a problem here. There's two circles there. There's an orange one and a blue one. So let's be a little bit more precise. So we don't want to do pi r squared. R would be part of the orange circle. We want to do the radius of the blue circle, which is L. And by the way, L is the slant height of the cone. Okay. Secondly, notice I don't have any degree measurements on this at all. But I do know, here comes a little bit of a leap of faith, I do know that X, which would be the central angle, right, over 360 would give me a percentage out of the entire blue circle. I could write that a different way. Our book chose to put X over 360. They also could have said the arc length over the entire circumference. Now, the arc length of ABC there divided by the entire circumference of the entire blue circle would be the same percentage. So I'm just going to choose, instead of writing X over 360, to write the arc length. How long is it from A to B to C, right? Divided by the entire circumference of the blue circle. That would be the same percentage as if I did the central angle divided by 360. So we would get, if it was a semicircle, right? The central angle would be 180. 180 divided by 360 would be 50%. If we did a semicircle, the arc length divided by circumference would also be 50%. So that's where and you'll see why I'm using this here in a second. Why did I write pi L squared? Well, remember, I'm doing the blue circle, not the orange one. So the blue circle, the radius is L, which is the slant height. Okay? So how is this going to make my life easy? You'll see here in a second. So let's see, arc length. How far is it around ABC? Well, once again, I got a formula for it, which is really complicated, but we're going to be helped along here by the fact that look where that blue sector comes from on the cone. ABC would wrap around the orange circle, right? That would be the edge of the base of the cone. ABC, can you see that? ABC would wrap around the circumference of the orange circle. And I know what the circumference of the orange circle is. The circumference of the orange circle would be 2 pi r, right? How about the circumference, right? The circumference of the blue circle, well, the blue circle has a radius of L, so that would be 2 pi L, not 2 pi R. So all I did there was write the arc length, right? That's the numerator. Where did I get 2 pi R? Well, remember that ABC, the arc length, would wrap around the orange circle. And the circumference of the orange circle would be 2 pi R, radius of R. The circumference of the blue circle, like all the way around the circle, would be 2 pi R, except in this case, R is actually the letter L. Hopefully that made sense. Why did I do all that? Because I didn't know what the arc measure was of this. Okay. Okay, look, there's a whole bunch of things that cancel. Well, the 2's cancels, the pi cancel. One of the L's on the bottom cancels. One of the L's on the top cancels. What do you mean top? See the pi L squared, right? So one L on the bottom, one L on the top. I would be left with L. I'd be left with an R, a pi, and an L. I'm just going to rewrite them in a different order. That's pi RL. So what is the lateral area of a cone? I just proved it to you. It's pi RL, where R is the radius of the base and L is the slant height of the cone. Drum roll, please. That is Theorem 12.7. So Theorem 12.7 says that the lateral area of any cone is equal to pi times the radius of the base times the slant height of the cone. Now, for those of you that are actually flipping through the pages right here, the book doesn't necessarily say it this way. They didn't even try to prove it to you. I just proved it to you, by the way. They just make a blind statement, and it's kind of hokey. I don't like this. I did use the same formula they used. They have a different one as well, too, but when they do their canceling, they get back to pi RL as well, too. They just didn't choose to prove it to you. I chose to prove it to you. Okay. So long story short, you got to multiply pi times the radius times the slant height. And oh, by the way, we leave things in terms of pi, so it's just the radius of the base times the slant height, and you're done. That's the lateral area. So once again, our book chooses not to make this a theorem, so what would be the total area or the surface area? Well, it would be the lateral area, which is that formula, plus the base area. The base is a circle. Once again, I don't find that formula right there very useful. The yellow one, which is I find the most useful, because we know that capital letter B is pi r squared. So tonight for homework, when it asks the total area, it's 2 pi r h plus pi r squared, where r is the radius of the cone, and the radius means the base, and h is the height of the cone, and then obviously pi is pi. Now I'm hungry. Ready to do one? Okay, let's do one. So there's cone. It's got a radius of 3, a height of 6, and a slant height of L. Well, remember, in order to do surface area, we need that L value. All right, so there's our formula. What do we know? We know the R. There's no H involved in our formula. And we're going to use the H there in order to calculate the L. Notice what kind of triangle did we just make there? Yeah, we made a right triangle. So we can calculate L just by using Pythagorean theorem. So let's see. 6 squared is 36. 3 squared is 9. It gives me 45. So L is equal to root 45. Okay, now I got the numbers I need. L is root 45. R is 3. I'm just simply going, oh, by the way, I didn't realize that. So let's see, 9 times 5 is 45. Square root of 9 is 3. So 3 root 5. Sorry about that. So now I'm going to plug in 3 root 5 for L and 3 for R. And then just simply do the math. Okay. Let's see. 3 times 3 is 9. Notice I'm not doing anything with pi. And it is a, I don't know, not a very satisfying answer when we don't multiply by 3.14, but it is the answer. Make sense? All right. If you need to rewind and play that again, please do.
To fill the cylinder, if it is 1/3 of the volume. So let's fill the cone up the first time. And into the cylinder. Let's fill up our cone for a second time. And a third time. cylinder if it is 1/3 of the volume. So let's fill the cone up the first time. And into the cylinder. Let's fill up our cone for a second time. And
so there's your formula. Okay, so it's basically 1/3 of a cone. Remember, a cone's formula is pi r squared h, where both the cylinder and the cone have the same radius and the same height. Make sense? How come I can't prove it to you? It turns out it's complicated. It's really complicated. It's very easy to do with calculus, but it is not something that you can do without some calculus. So this is the one formula, and we also, if I get to, I'm not sure if I'll get to spheres. When we get to spheres, that's the other formula I can't prove to you either without some calculus. So enjoy until calculus. Okay, so the volume of a cone equals 1/3 the base area times the height of the cone. The base area is a circle, so it's pi r squared. Let's do one example. So this is that same cone. This one isn't that challenging because we already know the radius and we already know the height. So the radius is 3, the height is 6. I guess you could mix the numbers up. I could also give you the diameter. If I gave you the diameter, cut it in half. I could give you the slant height and not the height, and use the Pythagorean theorem to calculate the height. But yeah, this one's not too challenging. 3 squared is 9. Half of 9, 6 divided by 3 is 2. 2 times 9 is 18. So we get 18 pi cubic units. Makes sense? Okay. So that will do it for today, ladies and gentlemen. Here is your homework. If you have any questions on any of the homework, please email. I'll be happy to help you. If not, remember, quiz will be on Monday. You'll need you'll have 2 links. The first one will be the quiz. It'll be a 15-minute quiz. You can use calculators and obviously your book of truth. All the answers will be, I believe, I got to check my worksheet generator. I'm not sure if I can do it in terms of pi or not. I'm pretty sure I can. Leave the answers in terms of pi. If not, I'll give you a quick video introduction of what I want you to do. Don't panic. So it'll just be on 12.1, 12.2, and 12.3. All right, guys. See you on Monday.
1/3.
Okay, so obviously that's clearly not a proof, but at least gives you the idea that if a cylinder and a cone have the same base area, in other words, the radius are the same, and the same height, that 3 cones make 1 cylinder. So if you're going to calculate the volume of 1 cone, it would be the cylinder volume formula divided by 3.